video will cover the end of the lesson, cover on Monday, November 30th, and because of the week before the Thanksgiving break, we did not have fourth period. I was not able to finish everything that I have planned today, so please, if you are watching this video, do not stop or fast forward, and just listen to everything I have to say. We're going to continue here factoring perfect trinomial squares. And we're almost done with this slides. If you don't have these two problems, just write them down on some notebook paper. And so what I'm going to do here is take the square root of 4m to the 4th. And so we know the square root of 4 is just 2, but the square root of m to the 4th will be m to the 4th divided by 2. Remember how that index becomes the denominator for an exponent. So this will be 2m squared. So the square root of this quantity here will be 2m squared. Now, since we have a positive sign here, we know both signs are the same. This one is negative, that means that both are negative. And so the square root of 1 is just 1. So that's the number that goes here and here. Now, this could also be written as 2m squared minus 1, everything to the second power. For my next problem, I'm going to try to factor out a GCF. I cannot really tell what the GCF is just by looking at the three terms. What I know is that I can take the variable with the smallest exponent, so that will be x. To find the numerical part of the GCF, I'm going to do a prime factorization of the coefficients. So 162 could be divided by 2. 81 could be divided by 3. 27 could be divided by 3. And 9 could be divided by 3 again, and 3 can only be divided by 3. For my next number, 144, prime factorization, we divide by 2. We do that, we get 72. We could divide by 2 again. In this case, we will get 36. Divide by 2 again, we get 18. Divide by 2, we get 9. Divide by 3, we get 3. Divide by 3, we get 1. So here we have the prime factorization of those two numbers. We have one more number to go, and that is 32. So 32 to be divided by 2, that's 16. Divided by 2, that is 8. Divided by 2, that is 4. Divided by 2, that is 2. Divided by 2, that is 1. So now I'm going to list my three numbers. 162, the prime factorization for that was 2 times 3 times 3 times 3 times 3. For the number 144, prime factorization was 2 times 2 times 2 times 2 times 3 times 3. And finally, for the number 32, our prime factorization was 2 times 2 times 2 times 2 times 2, or 2 to the 5th. So now we're going to say, we're going to find the numbers that are in common. And so the GCF, the numerical part of the GCF, will be the product of those factors that are in common. So all of them have a number 2. And let's see, what else? And I believe that's it. All of them have a number 2. So the numerical part of the GCF is going to be 2x. So that's what I'm going to factor out from here first. If I do that, factor out 2x from here, I will get 81x squared. Factor out 2x from here, I will get minus 72x. And if I factor out 2x from here, I will get plus 16. Now, you can see that 81 is a perfect square, x squared is also a perfect square, and 16 is also a perfect square. So because of that, I could say that this is a perfect trinomial square, and therefore I can factor it into two binomials, where I take the square root of this term, so that will be 9x, and I take the square root of this term, and so that will be 4. And for our signs, we know that here we have a negative, so we must have negative and negative here. So that is a way to write it down. Another way to write it will be 2x times 9x minus 4 squared. And that is the end of the slides. Now what I want you to do is to take out some notebook paper, and we're going to go over other things. And so this is what you're going to title Factoring Special Products. So please go ahead and title your paper Factoring Special Products, and I do want you to copy all the problems that are here. We only have 4 slides to look at. We're going to look at what happens when you have a difference of squares. And then on the last 2 slides, we're going to talk about a sum of cubes and a difference of cubes. So I'm going to pause the video. So if you do not have enough time to copy down the problems, feel free to pause the video again. So what we're going to do here, we call this a difference of squares because we're subtracting 2 perfect squares. And so we know that they are perfect squares because they are terms or numbers where you could take the square root and get an integer. Or, for example, any variable with an even power, for example, a to the power 6, if I take the square root of that, is the same as saying a to the power 6 over 2, which is a cubed. So even a to the 6 is also a perfect square. 25, of course, is a perfect square. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64. So if you're not very familiar with the squares, then you might want to write them down, just get familiar with them. 10 square is 100, 11 square is 121, 12 square is 144, and 13 square is 169. So this type of factoring is pretty simple, but it could only be used if there's a difference of squares. If you have something such as a squared plus b squared, that is not a difference of squares, therefore it's not factorable, because that is actually a sum of squares. So let's see what we do. We take this term into consideration and we take the square root of that, and so that will be x. Now we take 25, take the square root of 25, and that will be 5. It could be 5 or positive 5. And that's another reason why we use positive and negative. And that's it. That's all you have to do to factor a difference of squares. So let's look at the next problems. For example 2, part A, we have the square root of 4x squared. So the square root of 4 is 2, the square root of x squared is just x. We'll have 2x, 2x. The square root of 1 is just 1, or negative 1. And so that is the answer to that. For part B, we take the square root of 25a squared, so that will be 5a. And then we take the square root of 9b squared, so that will be 3b. We make one positive, one negative, and that's it. That is our factorization. Now, the one that we have here, it does have a fraction. You don't need to be afraid of it. So y squared, the square root of that is y. We make one positive, one negative. And now for the square root of 4 over 9 is the same as the square root of 4 divided by the square root of 9. And we all know the square root of 4 is 2, the square root of 9 is 3. So that will be 2/3 and negative 2/3. And that's it. That's the answer for it. Let's go to the next slide. So I'm going to go ahead and pause the video so you can have time to copy all of those problems. If you need more time, feel free to pause the video yourself. Okay, so now we have x to the power 4. And again, it is a perfect square because we're going to take the square root. And when we take square roots, the exponents become fractions. And this little number called the index becomes the denominator of the exponent. So x to the power 4 over 2 becomes x squared. So what that means is that the square root of x to the power 4 is x squared. Now, similarly, we could take the square root of y to the power 6, and that will be y to the power 6 over 2, which is y to the power 3. So what I'm going to do here is factor the difference of squares. Again, it is a difference of squares because we're subtracting, and the powers are even numbers. So this will be x squared, y cubed, we make one positive and one negative, and that's it, we're done. Now let's look at the next problem, example 4, part A. And so here's something interesting is going to happen. First, we will have the square root of y to the 4th. It's actually y squared. And the square root of 16 is 4. Positive and negative 4. Now, you might realize that here, this one is also a difference of squares. So we can keep factoring a little bit further. So the square root of y squared is just y. And the square root of 4 is 2, plus and negative. And so this will be the complete factorization of that difference of squares. The next problem here, we will say this one is not factorable because it is not a difference of squares. In fact, it's a sum of squares. We're adding them. Okay, and there are two more problems here on this slide. So if you have not written them down, let's do it at this time. And these are like difference of squares that are a little hidden from us. We can't really tell the difference of squares at first sight. But what we can do is see if there's a GCF that could be factored out, and that is the case for problem number 5. The GCF that I'm talking about, we cannot take a numerical value, but we can take a variable, and that would be x to the first power. So if we factor x to the first power, we will get 4x squared minus 49. Now you could see clearly that 4x squared is a perfect square, and so is 49. So we're going to factor that binomial into the product of two binomials. So the square root of 4x squared is 2x. The square root of 49 is 7. We make one positive, one negative, and that's it. We're done. Now the next problem, the GCF is not going to have a variable. It's just going to have a number, and that number is going to be 2. So we factor out a 2, and if we do that, we will get 81x to the 4th power minus 1. Now from here, we can factor this part as the product of two binomials. So the square root of 81x to the 4th power will be 9x squared. And now the square root of 1, it will be 1. Make one positive, one negative. But now if you notice, this one here is also a difference of squares. So we're going to factor it one more time. This one here remains the same because it's just a sum of squares, not a difference. However, here we could take the square root of 9x squared, and that is 3x. Square root of 1, that's 1. Positive, negative. So for this difference of squares, we actually end up with 4 different factors. 1, 2, 3. Okay, now the next one, what I'm going to do here is I could rewrite it so that it says 16 minus 49x squared. And this could be factored as follows. The square root of 16 is 4. The square root of 49x squared will be 7x. And we make one positive, one negative. And that could be a valid factorization for it. Now the last thing I need to cover is finding the sum or difference of cubes. And remember, with squares, we were only allowed to factor difference of squares, but with cubes, we could do both, the sum and the difference. So the first example, it is a sum of cubes because we're adding. So because of that, I'm going to be using this formula here. And in case you are not familiar with the cubes, 1 to the third power is 1, 2 to the third power is 8, because that is 2 times 2 times 2. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. And I'm going to stop there. So what I'm going to do first is determine which formula I need to use. And if you notice, the first factor, it becomes a binomial, that is just adding the cube root of the first term. So that goes here. And the cube root of the second term. Like that. Now, if we follow the formula, it says here that we take the first term and we square it. When I say the first term, I mean this x here. So we'll have x squared. Now, if you look at the last term, it will be the second term squared. And now, something interesting is that when you're factoring the sum of cubes, your sign here is actually going to be a negative. So it will be minus the product of the first term times the second. So x times 2, and that is 2x. So just to finish this up, it will be x plus 2 times x squared minus 2x plus 4. Now the next one that you see here is a difference of squares. I know that because there's a big minus in front of them. So I'm going to use the second formula. So first thing I need to do is take the cube root of y cubed, and so that will be 1. Then we follow the sign, so it's minus, and now the cube root of 27, and so that is equal to 3. Now the formula states that we take the first term, which is y, and we square it. We take the second term and we square it. And now if we started with a difference of cubes, then this side for some reason is positive. And it will be plus the product of y times 3. And just to finish, that will be the end of it. So we have one more slide. So for example 10, we're going to have a sum of cubes. And so we take the cube root of 64x to the third power. The cube root of 64 is 4, and the cube root of x cubed is just x. And the cube root of 1 is just 1. Now what we're going to do next is take this term, the 4x, and we're going to square it, because that's what the formula tells us to do. However, you need to make sure that you square also the coefficient. The next part will be minus the product of 4x times 1, and then plus the second term squared. And all I'm doing is following this formula. A squared minus AB plus B squared times A plus B. Okay, so 4x squared, that will be 16x squared. Negative 4x times 1 is minus 4x. And then 1 squared is just 1. Okay, and we have one more to go. This is the last one. And for this one, you could tell that the numbers are not perfect cubes. However, we could factor out by a number. And let's see if we could factor out by 2. So 54 divided by 2 is 27. And 27 is a perfect cube. Also, 16 divided by 2 is, or negative 16 divided by 2 is negative 8. So now here what we have is a difference of cubes. So what we need to do first is the term that will go here is going to come from taking the cube root of 27a to the third power. And so that would be 3a. And then we need a minus. And the term that will come, that will go there, will come from taking the cube root of 8b to the third power. And so that's going to be 2b. So now the term that goes here, it's as follows. It will be 3a squared. Then we need a plus 3a times 2b. Now we need a plus, and it will be 2b squared. And what I'm following is this pattern here, which says a squared plus ab plus b squared. However, my a happens to be 3a, and my b happens to be 2b. So now just to finish this problem up, 3a squared, we also square the coefficients, so that's 9a squared. Here we multiply the coefficients, 3 times 2 is 6, a times b is ab. And here 2b squared, that will be 4b to the second power. And so this will be the final answer for your factorization. And this concludes the video.